So in this lesson, we've seen that there's a couple of different ways to represent a system of linear equations. And the first one that I already have up here on the screen is what we call a vector equation. So I'll start by labeling this as a vector equation. And I can recognize that it's a vector equation because it's an equation that has vectors in it, right? So these are my variables x1, x2, x3 being multiplied by some vectors equaling another vector. So that gives us a vector equation. Now, another way of denoting this is by writing this as a system of equations. That might be more what you're accustomed to, like 3x plus 5y equals 7, 2x plus 4y equals 8, something like that. So what we want to do is turn this vector equation into a system of equations. So that's our goal here in the first part, system of equations. Okay, and to do this, I think about how vector multiplication and addition, scalar multiplication and addition work, right? I can think about this x1 as being scalar multiplied by that vector. So I can think about sort of distributing that x1 into the vector, right? So like x1, x1, negative x1, 0, and do the same for x2 and x3. Then I'd have a vector plus a vector plus a vector. And I know when I have vectors being added together, I can do that component-wise. So in the first slot, I'd have an x1 plus 3x2 plus negative x3, or minus x3. Then when I have two vectors equal to each other, I can set the corresponding entries equal. So in the first slot, I'd have x1 plus 3x2 minus x3 equals 0, and that's exactly what our first equation will be. So I'll have x1 plus 3x2 minus x3 equals 0. Okay, and then we'll do the same for the other three slots. So x1 plus 3x2, and then plus 3x3 is going to be equal to negative 8. Okay, and then in the third slot, I'll have negative x1, and then minus 3x2 minus 4x3 equals 10. And then finally, 0x1, 0x2 plus negative 3x3. So I'm going to write this over here just to kind of keep all the variables stacked, right? We have x1s, x2s, and then x3s. So negative 3x3 equals 6. And for now, we're not worried about solving this system, right? We're just worrying about writing it in different ways. So I could start with the vector equation, write the system of equations, or I can go vice versa. If I have the system of equations, we can go the other direction and write the vector equation. Now, another thing you'll see is that we sometimes write this as an augmented matrix. So what that means is we're just basically encoding this information in a matrix without worrying about writing all of the variables. Right? This is very long and tedious to write out x1, x2, x3 over and over and over again, especially as I'm doing the work to solve the system eventually. Right? So I want to be able to encode this information in a matrix without having to write all the different variables. So let's consider the augmented matrix. And here we think about each column is going to represent one of our variables, and then we'll have a solid line, and then the stuff on the other side will represent our constants. So I'll make a matrix here. Each equation is going to give me a row, and each variable gives me a column. So I have 1x1 plus 3x2 minus 1x3. We use this vertical line to kind of simulate the equal sign. So equals 0. Then 1x1 plus 3x2 plus 3x3 equals negative 8. And I'll put brackets over here to finish that off. Notation is super important, so make sure you're using correct notation. Then negative 1, negative 3, negative 4, and 10. And then finally, 0, 0, negative 3, 6. Okay, now what you might notice is that the columns in my augmented matrix are exactly the same as the vectors in my vector equation, right? If I smush those together, it exactly follows that same pattern, right? And that's not a coincidence. That's exactly how we've moved from one to the other here. The other thing we might be interested in doing is just writing what we call a coefficient matrix, and that's just this piece right here that deals with the coefficients of the variables, but doesn't care about the equals. It doesn't care about those constants that we're equal to. So we can also write the coefficient matrix. And this loses this piece here. So for the coefficient matrix, I would have 1, 1, negative 1, 0, and then 3, 3, negative 3, 0, and then negative 1, 3, negative 4, negative 3. So we lose a little bit of information with our coefficient matrix, but sometimes this will be useful for us. But in general, what I want to focus on here is these three main types to represent a system of equations, and you should be able to move between any one of them, right? If I give you the augmented matrix, you can come up with a system of equations and the vector equation. If I give you the vector equation, we come up with these two and all those different possible combinations.